Hey folks, welcome back to the video. Today we'll talk briefly about what we built last year, and then I'm going to tell you what I want to build for next couple of months. So we had a UI like this where a user could send a query and then get a response back from our own local LLM. A couple of things were returned, like the request matrix with latency, the total number of tokens being used, and so on. And here, like, our Kubernetes cluster was a pretty simple cluster. I'd say it was a single node cluster where we had two different pods, one for UI, one for our LLM itself, which ran on vLLM, and then there was a service for respective pods to interact with them. We had a config map where we defined a bunch of variables, and then the monitoring pods to make Grafana Prometheus happen, right? And in Grafana, we monitored a couple of things that was important for our metric. So what I want to do for next 3 months is this. So we'll keep the traffic flow pretty much same. So the traffic flow is going to be like a user will interact with our application through a wave interface, right? This wave interface, initially we had this wave interface will send the traffic directly to our LLM pod and then get a response back, right? But now what I want to do is I want to implement the logic of model router. So what this does is that it will check the incoming query, and then depending on the query, it will have 3 options, right? So think of something like we have ChatGPT 3, 4, and 5. So it will decide which pod or which model should answer that query, right? So should it be answered by ChatGPT 3 or ChatGPT 5? And why have something like this? So imagine, the query is pretty simple. How many days in a leap year, or how many days in a week? Something like that should not be handled by a higher model, right? We can keep that for more resource intensive queries or more detailed queries, right? Something like that can be easily handled by ChatGPT 3. And then if the query is a bit more complicated, we'll send that to ChatGPT 4. And if it's really complicated, we need our strongest model, then only we'll send it to ChatGPT 5, right? So, but this logic will happen in the back end. So I'll have some form of user interaction, like a feedback loop. So what will happen is a user will write a query. For example, can you explain how do I learn AI and ML in 2026, for instance? And initially, ChatGPT 3 will answer that query, and user will get a thumbs up and thumbs down button. If the user is not happy, thumbs down. If something like that has happened, then that data is fed back to the model router. Now my model router will know that, okay, the user was not happy with the last response that we sent. That was handled by, for example, ChatGPT 4. So now it knows that sending it to ChatGPT 3 is not the ideal thing to do. It will send it down to ChatGPT 5, and the user will get a response back from a better model, right? So this model is going to get the query that user asked, and then the response that ChatGPT 4 gave, so that ChatGPT 5 now knows not to make the same mistakes that ChatGPT 4 made, or give a better answer, even, so that's going to be the feedback loop. So there will be I will implement some logic and model router, right? Apart from that, there will be an LLM that will sit just kind of beside here, that will kind of make continuous improvements in the model router query, right? So that model router gets smarter and smarter over time. So how will we do that? From a high level, this is going to be my architecture. So I kind of want to build it in a way that it's ready for production. Let's say, of course, mimic production. So we'll have 2 parts for each model, right? 2 parts for ChatGPT 3, 4, 5, and then model router will have 2 parts as well. We'll have 2 parts for UI. So just in case if something goes down, we have a backup, right? And we will try those things as well. We'll try to take one of the parts down, and we'll see how our production behaves. And we'll do a lot of stress testing. We'll design some failures. So let's talk about the model router a little bit. I think what I want to do is all the data that the model router has will be saved in an in-memory database like Redis. So it's super fast because that all of that information is saved in memory rather than in storage, right? Like rather than in disk, let's say, which is much slower. Memory is much faster. So all of that data will be saved over here. Then my model router LLM, let's say that this model here, right? This model will be feeding or looking into that data continuously, and then it kind of notices that, oh, okay, so far, these are the user interactions, these are how many dislikes I've received, these are an example of some queries going to ChatGPT 5, some queries going to ChatGPT 4, and so on. And based on that data, it will kind of go through a data evaluation loop where it will check things like, okay, which model was chosen, the latency, the number of tokens, what about the user feedback. So over time, this data set over time, this becomes the data set itself, right? That will tell us that which routing decisions were correct, when they were wrong, and what kind of escalations happened too often, right? So the model will then propose a change, and we will review that change and apply it to production without causing any downtime. So I don't want the model to update my model router logic real time, because I kind of want to have some sanitation before I do that, because what if that change is corrupt in some way? What if that change takes my production down? So eventually I will move it in such a way that I'll have a pipeline. We will do some unit testing. After those testings are passed, then we'll apply those updates automatically in a rolling start. Maybe one model router gets updated, and then after that is fine, stable for a while, then another one gets updated. But those things are for future. But this is what I'm going to build for this year, and hopefully in 3 months time we'll have some good working solutions. And yeah, I hope I'll have fun, and I hope you guys will have fun watching this as well. And thank you for watching this video.